Hi, everyone. Good night. How are you guys doing? So, thank you all. Thanks Vincent and everyone from the AJUG for hosting us here. Has been great. We're in this crazy tour around the U.S., right? So you can see on the map here, or actually the map right here. We started in Austin. We're going to go all the way to Orlando and then quick stop in Chicago before we travel back. And, we are doing the whole thing in an RV. I think we can actually see the RV from here. Just park it right there outside. So if anyone wants to come and join us on the RV later on and say hello, we are visiting Java groups all over the cities to try to get some excitement around Java and answer questions and talk about cool things. I have a crew of people here with me. I'm not sure. I was kind of wanting to introduce them when they stay, but I'm just going to say a little bit. So it's me and Otávio from Brazil, Otávio Santana, right there. Say hello, Otávio. Right, Otávio Santana is a committer from OpenJDK. He's a committer from Cassandra, so it's a cool guy. Been doing a lot of open source software. So he's working on Java 9 right now. He's working on Java 8. I also have from France, but she actually lives in the US, but Yolande Pourrier. Say hello, Yolande. So who here who here is on Twitter? Okay, pretty much a lot of people. Who that's on Twitter follows @Java on Twitter? @Java? Just you follow @Java? That's the only person? Oh, there's only guy right here, right? You guys follow @Java. You have to follow @Java, right? @Java is the main Twitter account for Java on Twitter. And the person behind that account is Yolande, right? So she has like 315,000 people following her, right, on Twitter. So she's going to give us some cool ideas of what we can do to have that many people following us on Twitter. How about that, right? And she got scared, like, oh, I don't want 300,000 people following me, right? It's like kind of creepy, isn't it? All right. And we have, I'd like to say we have people from Brazil, like just, from Brazil, from France, and then we have some guy here from the free country of Texas, right? So Ian Schessler is an open source developer, Debian developer. He's going to be here with us in a minute, right? So, we brought all those crazy guys here, and we are just kind of in an RV 24 hours a day. You guys here are our break time, right? Because then that's the time that we don't need to talk to each other, right? So thanks for that. Let me ask you one thing here. There's a few things that we want to know, just so we set the pace here. First of all, who here is one of the things we're going to talk here today is about Java 9, right? So who here is already doing some experiment with Java 9? Has downloaded, doing some experiment? Cool, right? Who here has most of the things that you're running, running on production on Java 8? Yeah, almost everyone is on Java 8. Okay, who here is on Java 7? Okay, a bunch of people on Java 7. Who here is on Java 6? Yeah, there's a few people in Java 6, all right? Okay, less than that, Java 5. Anyone on Java 5? All right, okay, no one on Java 5. That's good. All right, so just a quick note. Moving up from Java 6 to Java 7 is a very, very good move, right? There's a lot of security improvements that you should do. I know that sometimes it's hard, but we got to say that, right? So, if you can move up, that's good. Java 9 is coming up. That means, the support, even the support for Java 8 is going to disappear pretty soon. So the sooner you can get moving up, the better. Okay, so that's about Java. Now, we have some discussion here about cloud computing. So who here is already using, very first question, who here uses any kind of virtualization, like VirtualBox or VMware in their computer or any kind of virtualization at all, right? Okay, lots of people. So who here has anything running on a cloud provider? All right, that's good. Who here is doing anything with containers? All right, pretty much the same group of people. All right, that's good. Who here, so you guys are doing containers. Who here is doing Docker? All right, everyone. Okay. So we're all on the same page here. Okay, that's good. What else do you want to know? That's it? All right. Oh, yes. Okay, so who is already using NoSQL? Any kind of NoSQL? MongoDB, Cassandra. All right, you're using those guys, right? Okay. What else you want to know? What do you want to know, Jan? That's it? Okay, that's good. All right. Sorry for you guys in the camera. You're not seeing who is raising their hand, but lots of people are raising their hand. Almost every question I ask it. Okay. So we're going to talk here. We're going to have lots of different topics here. And to start our conversation, I'm going to introduce this guy that's like a crazy guy. He's a guy that's kind of pushing me to do crazy things since I've met him. Actually, he's pushing a lot of people to do crazy things since he met those people. Ian Chesler is credited as being suggested Debian to create the Debian. What's it? The Debian contract.
The Debian social contract.
The Debian social contract. The Debian social contract was the basis of the open source definition, right? So he's the guy that pushed people to discuss open source before open source was even defined, right? He's an open source developer. He works on very, very cool projects. He's going to show us some stuff about robotics here. So put your hands together to Ian Chesler.
Hey, everybody. So I've been showing a little bit of robotic stuff because I also, in addition to, I make my main bread and butter doing Java contracting, mostly Java-centric contracting with web front ends. My brother and I have a small company in Dallas called Brain Food. But I also, starting when we participated in the first round of BattleBots back in the 90s, started to get into robotics just as a hobby. And so I have some stuff that, how many of you guys watched the Jimmy Fallon show? Anybody watch Jimmy Fallon, Tonight Show? So how many of you guys saw the realistic looking robot on that show, the Sophia robot? The guy who built that, we were roommates in college, and I helped build some of the animation system. So I'm just gonna pop it up real quick, just as for fun. Now we got sound? I guess not. So I'm gonna skip ahead. This SnakeBot thing, you should look it up on YouTube and see the SnakeBot. But so this is the robot that I helped build the animation system for. The can you guys see it? Yeah. I'm okay. I think I'm okay. Yeah. So I guess we can't do it. Should I skip the video? Can you guys see it? Can we hit the lights? Where are the lights? Oh, to mess the recording up. Should we skip the videos? Well, so quickly, like this robot has 40 motors in its face, and it can make basically every realistic expression that your face does. It mimics the structure of the motors in your face. It uses Blender, the free animation system. How many of you guys have ever seen Blender? Blender.org? You should check it out. It's awesome. What I did is I wrote a binding layer between Blender and the bone rig, that's what they call it in the animation business, to bind the bone rig, the position of the bone controls in the animation model, to drive through the robot operating system the positions of the motors to match the Pixar-like animation model. So, when animators at Pixar animate a character, they have this series of vectors and simple geometry that they can move around that control the expressions of the character. And then we just took that animation system and drove through the robot operating system with ross.org. You can check it out if you want to play with robotics, to drive the facial muscles. So you can look up Jimmy Fallon robotics and Sophia. So that's just kind of entertaining. I'm going to skip the other. I have also a video from 2014 that shows early stuff, but you can also find that online. So I'll just jump into my main talk. I'm going to give a talk that's mostly JavaScript centric, right? So real quickly, Bruno also, I have my Bruno slide because he always talks about how I talk him into crazy things. He always talks me into crazy things. So to give you guys some background on this talk, he called me and was like, we're going to do this Java tour. I was the original maintainer of Caffe back in the mid-90s on Debian, which was the first GPL version of Java, long before Sun open sourced it. So I was doing GPL Java, before there was any official GPL Java. So I am a Java guy. I do primarily Java on the server, but these days you can't really get away from doing a lot of JavaScript in your client. So Bruno called me and I said, what are you working on these days? And do you want to do this talk with me? And I'm doing a project with Mozilla about the new web extensions API. And he said, well, is it important for people who do Java? And I said, if they don't know about web extensions, they should definitely know about web extensions. So he said, well, you should go on the tour and talk about, how to use web extensions in JavaScript with Java. So how many of you guys know about Nashorn? Nashorn, right? All right, good deal. So I'm going to give, some talk about JavaScript, maybe boo, I don't know. And I'm going to talk about web extensions. And I'm going to talk about isomorphic applications. How many of you guys have heard this term, isomorphic applications? Basically just means code that you can run in multiple contexts, usually use the same code on the client and on the server. So I'm going to talk a little bit about that, and I'm going to talk about JavaScript frameworks like React and Vue.js. I'll talk a little bit about Filter Bubbler, which is a thing I'm working on with Mozilla, and we already got the robot stuff out of the way, so let's go. What are web extensions? Web extensions are a new API for developing add-ons to the browser in JavaScript where the GUI is HTML and the code is written in JavaScript. So it's pretty much the model you're used to developing in the browser, right? It just exposes additional tools into your JavaScript programming environment that you don't have when you're writing JavaScript in a page. So you can, for instance, ask for the history of the browser. Ask for where that browser has visited. You can see what tabs are open. You can open a tab. You can close a tab. You can create bookmarks. You can manipulate, basically you have the direct connection into the browser internals, and you can manipulate the browser internals. And it's portable. They're still not 100% synchronized across all platforms, but Chrome, Firefox, and Edge are largely similar, and with a polyfill, which is basically like an adapter class, you could think about it as an adapter class, you can get it to where you can get one set of code, run it in each of those environments, right? So it lets you add a button to your browser bar, you hit it, this is basically an HTML page, but you can then put whatever logic that you want to put in there for, let's say you want to have something for your customer service reps that if they want to look up some order ticket number or something, they can, at the top of their browser, have a tool that's always there, boom, it talks to your Java server. You just use the same kind of UI infrastructure that you're used to using, React, Vue, you can use all those things in these add-ons. So you don't have to do it in C++, you don't have to learn like XPCOM or all this other kind of internal browser-specific stuff. So I kind of talked a little bit about this, so I'm going to skip ahead. I pretty much got this slide out of the way. So like a sample, just very simple structure might look like you always have a manifest, which is just a JSON file that lays out what other parts are going to be in your extension. And then you'll typically have a series of the UI. You can have both the pop-up, which is like what you saw there, and you can have it that when you click a link in the pop-up that you can open up a settings page, which acts just like any of your other extensions. If you click it and it takes it to a full page where you can set settings for your extension. So, and then the interesting thing is you have a background context that runs all the time, right? So every time you press that button and the pop-up comes down and goes away, that context resets each time you do that. It's just like hitting reload on a web page. But the background script starts when the browser starts up and it stays there. So you can have background script logic that's running all the time and retains its state all the time while the browser's up. And then you can also inject content. You can inject scripts directly into the content, right? So you can have your plugin, your extension can sit there in the background and watch, let's say you're at work and you have a legacy HTML system, right? And you want to have it that, let's say you have the old ERP system and the new ERP system, and you're in the, you're having to sit there with, people are sitting there with two browsers open and they're copying stuff by hand, right? Here you can have a plugin that can reach in to that one page, talk directly to the DOM and to the JavaScript context in that one page, and then reach over and dump data into the other page. You can directly manipulate the insides of those pages, just like your code was part of those pages. So isomorphic applications, right? Those are, that's code that you're going to run in multiple contexts. So what kind of value can you get out of this? So like, let's say, how many of you guys have written HTML form validation logic, right? Everybody's done that, right? So now you validated your form, you made sure maybe the social security numbers got the right 3, 2, 4 sets of digits, whatever, and now you're sending it to the server. You can't just not check it again, right, and write it to your database. You got to check it again. So a lot of times you end up writing validation logic once again in Java. You know, you have your JavaScript version, your Java version, and now maybe you start adding mobile apps. All of a sudden you got your Objective-C version, your Android Java version. You have the same code, engineering hours for the exact same logic going in all these places. So you start asking yourself, if it's not super performance critical, can you just use the JavaScript logic in other contexts? So there's actually a couple of ways you can go on this. You can take JavaScript and bring it up to the server and run it with Nashorn, or you can use things like ClojureScript to take Clojure from your Java environment and run it in the browser. It compiles it to JavaScript. Or there's JSuite, which lets you just basically compile Java into JavaScript. So Nashorn is the JavaScript environment in the JDK. And what it does is it reads JavaScript and turns it into Java bytecodes, just like the Java compiler reads Java and turns it into Java bytecodes, right? The Java VM doesn't speak Java, the language, it speaks the bytecodes. So this is just a JavaScript compiler that compiles it into Java bytecodes. And this is how easy it is to use, right? Let's see these two lines. You can ask for a new script engine, Nashorn, and then engine eval, you can pass it a string that's JavaScript, and you'll, like if you return an object here, I'm printing, you know, something out, but you could, if you instantiate a JavaScript object and return it, that object, you can return it back to Java, and Java can call methods on that JavaScript object just like it was any other Java object, right? And you can go both ways. You can pass Java objects into the JavaScript context, and JavaScript code can invoke methods on your Java objects. So this lets you really take code, you know, in JavaScript and share it between your two environments. So the reality is applets are dead, right? That's not coming back. So as Java programmers, we've got to get used to this idea that we have to project our logic into these client environments. And part of what I want to people to understand is don't think about JavaScript as this thing that's separate from Java, right? Nashorn just makes it another way for you to use a human language, JavaScript, to produce Java bytecode that can be used in your application. And the tools like, how many of you guys have used Cordova, PhoneGap, right? So it's starting to get to where you can write one piece of JavaScript and you can be producing native apps and mobile web and full-size desktop web and server logic, all from one piece of code. And there's also a lot of interesting stuff happening in the JavaScript space, programming-wise, right? When things started out, I don't know how many of you guys remember, doing jQuery, get, and then you got your on success, and then let's say you got to chain up a bunch of gets that you can't do one until you've done the other, and so you get this flying V configuration, right, where you're like get, success, get, success, get, success, get, success, and then closing them all back out. Well, people got sick of doing that, so it forced people to innovate in that JavaScript space. And then you get the .then constructs, and now you get RxJS and immutables, and there's all kinds of cool stuff going on in the JavaScript space. So you can leverage that stuff in your Java applications. You don't have to start from scratch for some of these ideas. And we've already seen some major changes to Java because of this, right? Like async IO. That was mainly a result of Node.js putting pressure on Java, because when you had 10,000 simultaneous sessions on the Java VM before async IO, you had 10,000 threads, right? Whereas in Node.js, those are just basically entries in an array that you have a thread flipping between. You know, if a connection gets stuck because you've got a slow connection out to your mobile client, you haven't got a thread parked there waiting for it. You've just got a connection waiting for data ready. So leverage these tools in your Java program, leverage these programming constructs. Like React, Flux, and Redo. How many of you guys have used Redux? So Redux is a really different way to construct your programs, right? I'm gonna jump ahead here. because I'm going to be tight on time. You basically, how many of you done swing applications? So you got your event listeners, right? Everything's kind of written in this model that you press a button and it runs a function and you directly execute code right then. And when you combine this with async I/O, you can get these really complicated flow problems where it's hard to understand the flow of your program. So what Redux does is when you click one of those, let's say click that button, it doesn't take action directly, it submits an object to a queue that represents a request for action, essentially. And later a thing called a reducer is going to act on that request. But what this does is it gives you this flow of action objects, right? Like a deterministic flow of action objects. And then your program becomes like a player piano that's running off of this stream of action events. And that makes it so that you have a series of states that your program moves through. So like, let's say you got a to-do list application, right? And you're like, starts out empty to-do list, add a to-do list, now I got 1. Add a to-do, I got 2. Add a to-do, I got 3. Delete, I got 2, right? So the series of states is a deterministic result of the series of action events. So if you do something like, let's say, a feature toggle to capture these actions when you have an error and throw it back to your server, you can take that stream of actions in your dev environment, plug it in, play them back. You should get the exact same state back in your program that your customer got in the field. And that's a really different way to approach your programming. And that's kind of a JavaScript thing. Sure, there's Java stuff doing that, but this is like a major movement in the JavaScript space. And it makes it easy to do things like time travel and undo. Like, let's say you want to have undo in your application. Here, you can, if you hold the last several states, since the whole application just is held in this single state object manipulated by actions, you hit undo, you roll back to a previous state, the whole application snaps into place into its previous state. So I'm building a system with web extensions using Redux called Filter Bubbler, and it's basically a text analysis toolkit for your browser that lets you do the same kind of analysis that the big guys like Google and Facebook are doing to us all the time, right? But that we don't have those kind of tools ourselves to understand our own browsing habits. So, when Facebook is looking at all your friends' posts that they've all posted and deciding what they're going to feed you next, they're doing all kinds of sophisticated analytics on your behavior and the behavior of people who are like you, right? So they are trying to optimize to keep you on the system as long as possible, to try to get you to click on things, to purchase, to make purchases. And we're not aware even of how they're making those kind of decisions, let alone be able to analyze our own behavior. And this creates how am I doing on time? 3 minutes. Okay, so how many of you have heard the term filter bubble? So a filter bubble is this idea of cognitive bias, right? Which is that we surround ourselves with things that we like. You hang out with people you like in general, and you buy things you like. You subscribe to magazines and newspapers that show you things that you like. Well, that has jumped to another level now because search systems and social networks now are using sophisticated analytics mechanisms to feed us what we like, right? And so you get this super cognitive bias on steroids where you're completely unaware of maybe other people's ways of looking at the world. So disagreeable facts never reach us until maybe it's too late, right? We become disconnected from the world. So Filter Bubbler lets you do your own analysis on your own browsing habits. So like a very simple version, let's say we have, how many of you are familiar with Bayesian classifiers? Right? Bayesian classifiers, like what is used in Spam Assassin, or basically most spam tools. And what it does is it creates a statistical profile of text. It's mostly like taking groups of 5 words and building up a statistical profile of the groupings of 5, 3, whatever words in a given piece of text document. And for spam, for instance, if it's Viagra, Ugg boots, right, then it's like, oh, statistically this is probably spam. Well, it doesn't care that it's spam, right? It's just a statistical profile. So a fact I heard that was surprising is apparently that's how they grade SAT essays, right? They take, these are bad essays, these are good essays. Bad grammar has a profile, right? The wrong words are next to each other in a consistent, a statistically significant way, which has interesting implications about, consciousness and knowledge, right? So, but being able to perform these kinds of classifications on your own browsing habits is really interesting. So like, let's say you take a bunch of URLs and you just say, these are awesome URLs, these are stupid URLs. And the system will take the content of those pages and build up a statistical profile of awesomeness and stupidness. And then at a simple level, like you can say, I want to take the current page and have it spit out in a little pop down, this is awesome or stupid. But the system, it's pluggable, so you could take the source and have it be the last year of your browsing habits, and have the sink be a bookmark folder that it creates. So it'd create a new folder and create two folders in there, one called awesome and one called stupid, and then statistically analyze your whole year of browsing patterns and put all the pages that are awesome in one folder and all the pages that are stupid in another. But these are also pluggable. You could take all the articles that were on the New York Times separated by department. Take your year of browsing history and separate it into sports, drama, arts, etc., using the same kind of mechanisms that are used in spam classification. That's pretty much it. I think we're going to save Q&A to the end. No? All right, questions? If you ever use a spam filter. How much training do you have to do? Obviously, more training is better, but if you've ever used a fresh email account, you're using the same exact mechanism as training a spam filter. So, if I were to give a lot of it's going to depend on the differentiation between your document sets and how similar they are. So it's hard to give but hundreds, I would think you'll start, hundreds of samples, you're going to start getting a meaningful separation. Obviously, tens of thousands or hundreds of thousands, you're going to get a much more fine grain. Oh, and I want to mention the classifier is also pluggable, right? So while you can use a Bayesian analyzer, you could also use much more sophisticated analyzers, like anything that you could write in JavaScript initially, but we're going to even open it up to, using Nashorn. I'm going to play around with doing a Java-based one where the core system is JavaScript, but you can plug in an actual Java. Like if you want to use, the Stanford natural language processing infrastructure to do analysis, you could do that.
Back to the web extensions. I have the questions about the web extensions and really about the potential security risks that it would open up if I can control the browser with JavaScript. So all the things that I don't want the JavaScript to do, it can enable itself to do and do it.
Sure, absolutely. Now, of course, a web extension can't install itself on your system. You have to go into the add-on store and you have to add it. So it's really just exactly like an iPhone or an Android application. Sure, you install something hostile, it's dangerous, but it also has a permission system like Android applications where yeah, it's there, and when you install it, it'll tell you what permission, you're giving it history access, you're giving it cookie access, and you can go like, this is like a, whatever, this is a map thing, it doesn't need my cookies, clunk, not install it. Anybody else?
So Nashorn, I learned the potential, it's like a huge potential. So is there any negative disadvantage of Nashorn? Like, is it going to make it to a big time? Adoption?
It's competitive already with Node.js, and Java 9 continues to build on, Java 7 introduced Invoke Dynamic, which made a huge performance step forward. It depends on what you're trying to use it for, but I think for business logic,
the example that you give, the portability of the validation framework, I did something with RhinoScript, previous
Sure.
version of
Yes.
Nashorn.
Yep.
So you can, same kind of validation. So we had to do a JavaScript validation. We had to do the property validation on the web service, but then we don't have to repeat the logic. So I used RhinoScript, but it was awesome when I implemented the functionality. But Nashorn, is there any negativity? Why people are not using it?
Did RhinoScript met your needs, or? Yeah, I think in general, people who used RhinoScript like there's been a lot of users of RhinoScript, and I do a lot of work with the Apache Open for Business Open ERP system. Which if you guys need an ERP system, I encourage you to look at Apache's Open for Business system. But I used RhinoScript there for doing validation of just even SQL inserts in a lot of cases, and it wasn't the dominant. That in-memory JavaScript emulated logic wasn't the big O, right? That wasn't the dominant computational factor for me. And Nashorn makes that even smaller. I think there's so many engineering hours in the Java VM and so many people focused on JIT improvements that I think sooner or later Nashorn's probably going to really be giving Node.js a run for its money. And what you can't be is, like, let's say you take something like the disruptor that disruptor ring buffer thing, and you have like an 8 gig in-memory structure in your Java VM. You can do stuff with Nashorn that you just can't even do with Node.js, right? Node.js does not have thread constructs. You can't have like a big shared in-memory object. You have to pass everything across workers by reference, by value essentially. So there's stuff you can do with JavaScript in the Java VM using Java's like native superpowers that you just can't even think about doing in Node.js.
Yeah, I was thinking why nobody else is doing it. I'm the only person doing it.
I think it's a quiet revolution. I think because of the cognitive bias, right? There's a real tendency among Java programmers, even somebody goes, oh, I've been playing with JavaScript. Everybody's kind of like, oh, yeah, I don't know. Anybody? So take advantage. I'm here. I'm totally happy to answer questions. All right. Thank you.
All right. Okay. Thanks a lot, Ian. Yeah, we had to clap for him because the time was up, and we gotta, All right. Thanks a lot. I think this whole discussion, this whole idea of the cognitive bias, it's important for us because we kind of get stuck in our little world sometimes. And although the Java world is very, very big, sometimes it's good to see a little bit what we can do outside. And the JVM is so cool. There's more than 300 languages that runs on top of the JVM today. And so, every time people talk about JavaScript or Scala or Clojure or Kotlin or all of those languages, you can always remember that the Java VM runs, if not all, most of those languages. And we Java developers, we have easy access to all of those things. And it's good to keep this in mind and think about things. All right, so in terms of about open up our minds, this next guy here, is Otávio Santana. He's an OpenJDK committer, so he's working on Java 9 right now. He's working on Java 8. He's been traveling around the world talking about NoSQL, right? He's a committer of the Cassandra NoSQL database. He's been doing all kinds of projects with NoSQL for a long time. He's now creating a specification for the Java community process for the NoSQL. So put your hands together to Otávio Santana.
Hello everyone, good night, good evening, sorry. Who are Java EE user? Java EE user. Keep your hands up. So who also are using NoSQL database? Oh, that's nice. Thanks. Let's start to talk more. By the way, who are using microservices in your application with Java EE? Microservices? Anyone? Okay. By the way, who are Spring user? Spring Data? Wow. Whoa, man. A lot of people here. Actually, I really love Spring. Mainly Spring Data. That integration between NoSQL and Java made by this guy was amazing. But I'm here to talk more about specification. So let's talk more about what NoSQL is and this kind of stuff. That's my name, my Twitter, Otávio Java. otaviojava@apache.org. So as Bruno mentioned, I committed from Apache projects, some Apache products, such as Cassandra. But first, who knows what NoSQL is? Okay, a lot of people have no idea. So basically, NoSQL is a database. So you can put information there, you can retrieve information there, you can delete information there. But there is one different stuff. They normally don't use AJUG strategy. So basically, they don't have transaction. They are using base strategy. So they have 5 different types. Okay. The first type is key value. So it's something like hash map does. So basically, I have a key, and then I have a respective value to this guy. I believe the most famous one is Redis or Redis, Hazelcast. The document, the structure is something like JSON file or XML file. I believe the most famous one is MongoDB. Column family. This information here is something like the only field mandatory is the row key. The column is just in time. I mean, the column is gonna create it when you really need this information. So take example here. I have dirty. I have just Aphrodite has color because when I create information, that's appear. So that's a different from SQL technology because if you have information or not, the column already exists, but with new information. So I hope the most famous one is Cassandra. Neo4j, the graph. Basically, I can keep information and relationship between nodes and vertex. And multimodal. Basically, what multimodal is, if I have a NoSQL vendor that has support more than one type, so ORNDB has support to graph and document, that means this database is multimodal. So basically, multimodal is, okay, I'm a vendor, I have support to more than one type, so I'm multimodal. I believe that's really normal and trivial to try to do the comparison between SQL technology and NoSQL technology. You can see here the structure. So I have SQL that has table, room, column, and relationship. I have key value, the simplest one. So I have just bucket and key value per hash map. Document, I have the collection. I have the document, and each document has a pair. Basically, I have key value pair in each document because in the document we have the key, that's the name, and the value, that's the information. Something similar we have in column. That's I have a column family. I have a column that also has key value pair. So key is a value. Key is the name. Value is the information. And the total different stuff here in the structure of the graph. So that's a totally different from SQL technology and relationship stuff. So the first advice when you try to use NoSQL technology is stop to think more SQL. Try to don't use relationship on Cassandra. Try to don't use relationship on Couchbase. And that's it. Okay, let's try to compare again between relational application with NoSQL application. If you are use SQL technology, we have JPA and we have JDBC that are standard. So if I'd like to change between MySQL and PostgreSQL, basically I just need to change the driver. That's easy. If I'd like to replace Hibernate to OpenJPA, so I just need to change the implementation because this guy here and that side has standards. But in the old site, I had NoSQL application that is not standard. So If I'm using Cassandra and like to use Couchbase or Redis, I need to change everything. Of course, you have some solution. We have Spring Data, and we also have Hibernate OGM and TopLink. The idea behind Hibernate OGM and TopLink is, okay, the Java EE developers knows about JPA API, so just try to use the same API to these guys use NoSQL technology. So basically I try to use the same annotation, the same operation, the same entity manager to try to solve this kind of problem. But of course, JPA was not made to NoSQL technology. If you'd like to save asynchronously, I'm gonna have a problem. If you'd like to use time to live, I'm still gonna have a problem to do. So, in NoSQL we have a lot of diversity. Okay, Cassandra has a consistency level, and just Cassandra has CQL, because CQL is Cassandra query language. Okay, the huge challenge here is the diversity. So I have different types, I have different goals, I have different behaviors, I have different proposal to all kind of NoSQL database. Even you try to use the same type, the same key value, some banks, some database have different structures or different behaviors. That's why I'd like to create the new specification about that. That's JNoSQL. Basically gonna have two layers. The map layer gonna be something like the JPA does, and the communication layer, that's gonna be what the JDBC does. So basically you try to divide and conquer. Why? Because the communication layer, just the NoSQL guys, vendors care. And the mapping layer, the solution guys care. So Spring guys here, and the mapping layer, the Hibernate here, and the mapping layer, and Cassandra, Couchbase, Redis, and a lot of NoSQL vendors, and the communication layers. So I can divide and conquer. So JNoSQL is Eclipse Foundation product. It's a dual license, so Apache and Eclipse license. I have one API to different NoSQL types. So I have one API to key value, I have one API to column, I have one API to document, and I have one API to graph. Why Diana and why Artemis? Because I love this name, so that is it. Basically, my product, my name. Sorry for that. Why Diana? Basically, this guy gonna be the communication layer. Think more what the JDBC does. So I'm gonna have 4 different APIs, one for each different kind of NoSQL database. So document, key value, column, and graph. And take this sample here. We have 4 different kind of document APIs. So I have a RongoDB, I have MongoDB, I have Couchbase, and I have OrangeDB. These guys are document NoSQL database type. So if you take a look at the code is totally different, right? But if you take a look at the structure and the behavior, gonna be exactly the same. So I have a RongoDB, try to put a document. What we have in the document? So I have the name and the value. So that's a document pair. What I have in the MongoDB? I try to put a document. So a name and value, a name and value, and name and value. So you can see this guy here try to do exactly the same thing. Try to put a document inside in the database. So we don't need this. We just need one API to do this kind of stuff, because this guy here is a document. So what I try to do is give a document collection. I try to put a document there. That's exactly the proposal. So I have my document entity, I created the document that has a name and value, and then I put my document there. Given that, I have implementation from Couchbase, AroundDB, OrangeDB, and MongoDB. That's the whole idea about standards. So basically, I keep the same behavior and put in just one API. Of course, you have more issues. So basically, we have nomenclature issues. So I have insert or save, delete or remove. Just to try to keep the same thing, because, okay, I'd like to do exactly the same thing. So update or merge, find or search. The idea is, okay, I can have more behavior, but just try to use the same nomenclature. The time to leave is exactly the same thing. So I have long to seconds, into seconds, long to milliseconds, into milliseconds. I have 4 different types of nomenclature, 4 different types of the standards to do exactly one thing. Imagine right now, I'm a NoSQL vendor, so basically I have my database here, and I have my API. I'm gonna do an implementation, and I have a TC key. The TC key is Technical Compatibility Kit. So basically, I try to run my implementation here. It's that pass. Okay, I have support to Diana product, so I have support to communication layer. You try to keep the same nomenclature of JPA. So I have the configuration class that does configuration stuff, client stuff. I have factory that create managers that manage entity. So exactly something that we have on JPA. Of course, the diversity on NoSQL database really matter. If you take a look here, I have the common API on column. So I have a column entity. I put one column in the entity. So I have the common API, so I can save something, I can find something. So I have multiple implementation here. But to me, when I'd like to use Cassandra, the diversity and the behavior really matter. So I'm running the CQL. I'm running the Cassandra query language. I will try to save use consistency level. But if you take the return, so I'm returning the same API. So I have a lot of NoSQL providers on this project. So I have Cassandra, Couchbase, MongoDB, Oracle, AroundDB, Elasticsearch. I have a community. We have a lot of Java user groups. We have the Spring Data guy with us. Of course, we have the mapping layer. So the idea is, okay, I have the communication layer with CDI layer. So let's create Artemis. So everything is around annotation to make easier the communication between Java application and the NoSQL database. Who knows Spring Data is really common. So I have dynamic query, so method query. Basically, I can create a query based on the method name. I have a lot of events. So I mentioned before, the specific behavior in NoSQL database matter. So you can have a lot of extension there. So I have extension to put annotation such as UDT. UDT is user defined type. There's a type from Cassandra. And I have something like, okay, I have the CQL annotation that run query on Cassandra. Again, CQL is Cassandra query language. That's the roadmap. So we have some draft code and proposal, community feedback, NoSQL vendors, solution vendors. What solution vendor means It's a Hibernate guy, pivotal guy with Spring. Right now it's an Eclipse project. Here you are writing the code and write the proposal to become a GSR. We have a site, so genosql.org. You can go there and get more information. You join us. We have everything is open source in our GitHub, so let's do it. We have mail lists. We have Gitter too. So I believe I have no more time to show some codes, but let's try to do it. 40 seconds. Okay. Let's try to do it. Okay, set it here. Basically, that's our JAX REST API here. Basically, I create a hero resource. I have my entity here. Okay, thanks, brother. I have my entity here, so I have the hero guy, so I have my hero entity, so I have ID, I have column. Let's return it again here. My resource.
Can you guys in the back see? No problem. Yeah.
Okay. I have my resource here. Basically, I can find my hero by ID, my hero by some query. If I take a look here, my hero repository. Basically, I just have the interface, and based on the name method name, Artemis try to create a query to you. There's exactly something that Spring Data does, because Spring Data is working with us in this specification. We have one configuration guy here that's that's so difficult. A connection guy, so I have a connection here that's a local host, one host connection. Of course, I can put more guys. Host 1, host 2. I have my user and then my password. If I show here, let's give more zooms. Okay. Let's try to start my Couchbase machine. So, oops. Couchbase here. Let's try to start this guy here. Oops. And then I can start my application right now. If you take a look in my products, so I'm using just one PON, XML PON file. So I have some configuration here. Basically, what I have first my Artemis dependence, and also I have my driver, and that is it. That's the whole idea about GNOSQL. And I'm using microprofile. So microprofile is, I initiative to make microprofile and microservices on the Java EE world. Oh, what's the internet? Basically, on the Java EE world, I have a huge guy that is a server. And the idea is, okay, I would like to use Java EE, but I don't like to use JMS or JPA. The idea on the microprofile is, okay, let's take more small piece on the Java EE world. So it's not open here, but if you can go to microprofile.io, you can get a lot of information about it. We have a lot of implementation. And the first version has CDI, JAX RS, and JSON being processed. So basically, I just can have one microservice using just 3 libraries. That's the idea. That's the entire idea. Is there any question about it? Can you? The microphone.
I don't think I need a microphone. Oh, okay. Say, is there any concern, or do you have any concerns that an OR, creating an ORM for a NoSQL database is, I don't know, a solution looking for a problem. That's maybe it's not an ORM isn't necessarily a good fit for a NoSQL database, or maybe if you're looking for an ORM for a NoSQL database, you should be looking at maybe a relational database, because it sure seemed the entities looked a whole lot like they were trying to map back to a relational type structure.
Oh, that's a good question about the relationship. Basically, we are right now working on this kind of this behavior, and the answer is you are working in progress right now. If you join us, we have a discussion about that, and you can give your feedback. The idea is release it on the Java EE 9, so the Java EE 8 is coming in July. So we have more 2 years to work on the NoSQL project.
And I thought the same thing. Because I think MongoDB has their own ORM mapper also, and so I was thinking, oh great, I'll use this ORM mapper, and that way I don't have to worry about diving in and learning all the intricacies of their SQL query and all that. But I found out, but what I discovered pretty quickly was I still had to. You know what I'm saying?
Yeah, that's a good point. And that's why the first idea was, okay, let's try to use JPA annotation, that try to use everything that JPA has. And that was the huge mistake. That's why I created everything new to fit on NoSQL database. If you take a look on Spring Data, they created a whole annotation, the common annotation, and specific extension to different kind of NoSQL database. So if you are looking for Elasticsearch, I have a search engine. If I look for MongoDB, I have that stuff. So the idea is let's create a small API to keep everything there, and let's make easier to create extension. That's the idea. That's a huge challenge, by the way. More questions? Okay.
All right, making sure this is on. Usually whenever you're using an ORM with a traditional relational database, it's very much a trade-off of speed versus convenience, because as everybody here probably knows, whenever you use something like Hibernate, there tends to be a lot of overhead with it. So my question is, what kind of overhead are you seeing so far for JNoSQL, as opposed to going out directly to Cassandra or Mongo or any of those?
Of course, it's a one layer more. You become so slower, but not slower than Hibernate, because Hibernate is a huge guide. Try to figure out your transaction, but Cassandra have no transaction. Basically, the RTM is going to do is get your object and convert to Cassandra. That is it. So I have a little overlay, of course, but not too easy, such as Hibernate.
Okay, very good. Second question I had, I guess this is more of a social question. You mentioned getting cooperation from the other from the vendors. What kind of cooperation are you seeing? Because when you think about it, you're approaching them and you're saying, we want to make it easier to migrate off your stuff. Can you help us?
Actually, this kind of good question. Actually, do you know ScyllaDB?
Somewhat.
Basically, Scylla is a different NoSQL database that has exactly support to Cassandra. You know what it means? Basically, the people are looking for that. So that's when we write some emails about this, I thought, okay, the people don't agree with that. But they agree because the diversity matters to this guy, because a lot of people is scared to use NoSQL because it's so different to try to use. So they agree because more people get in the product. Okay. And we have extensions, so I cannot use Cassandra such as try to use MongoDB, because this guy has specific behavior. You're going to have a specific extension.
Right, a little too different than anything.
Yeah.
Okay, thank you.
Okay.
That's it, Otavio?
That's it. Thank you, guys.
All right. Thanks, Otavio. I just want to compliment those last questions about the standards. You know, it's every time we talk about standards, there is like layers on top of it and all these kind of things. And the reason why we have these standards is to allow you to write your application independent of the vendor, right? And you know, there's different ways of doing this. There's a lot of it. We know it works because there's a lot of applications out there that depend on the Java VM, for example, that's independent from the OS behind. There's a lot of Java applications that's independent from the application server. And then you can say, you know, our friend over there said, well, you know, but in the end, I still have to do a little bit of, you know, some of that. Yes, you know, the good thing about this standard is that it allows you to do the direct integration with whatever vendor you want when you need that integration, right? But you know, most of your code will not depend on that, and what it allow you, you know, what was impossible before to migrate from one vendor to the next, it turns to be possible, right? Not necessarily magically possible, but you know, and that's important because we're going to be talking about now a little bit about containers, and this is a very important movement right now. And since most of, not most of you, but like maybe, you know, a group of you guys already doing Docker and everything, but there's a lot of people here that didn't raise their hands doing containers. So, you know, let me kind of give you a general overview and some of the things here. And it has everything to do with standards, right? Has absolutely everything to do with standards. You know, you all know here when like we talk about software containers, right? But you know about the real world containers, right? Because you've seen those big boxes, right? Going through in the ports, in the you know, inside trucks or trains, right? You've seen those like big iron boxes that we use for shipping containers, right? And the real world containers completely change the way we do shipping in the world. You all know here how we ship things before the containers, right? Because you all here watched Titanic, right? Who watched Titanic here, right? Everyone watched Titanic, right? So you remember that moment where Jack and Rose, they were all, you know, in the cargo area of the ship, and they're running, all happy, blah blah blah. And you remember, you know, the hands in the window of the car. You remember all of that, right? You don't remember what was behind them. So behind them, you could see all kinds of boxes stacked on top of each other and things tied by ropes and nets, right? That's the way we shipped things in the past. It was like very, very manual work. And someone is marking the time? Yeah, okay, good. Because I forgot to mark. Okay, so we have all of these going on. It was very manual process, right? Very labor intensive. And it means that, you know, you wanted to ship something, you had to get to the port, and then, you know, you have all those guys looking what you had, and they had to tie it up, you know, like a bicycle, or, you know, the box and the other box and everything. And then at some point, someone, you know, after the Second World War, someone came up with this idea of having a big box, right? How hard it is to come up with that idea, right? Okay, it's easier to put a big box inside a ship, so let's make a bigger box, and let's make a humongous box, right? And then we can put this whole thing inside the ship. And this, you know, it's not only about the size, right? It's all the hookups and everything, so you can get the cranes, and the cranes can come in and move the things around. And once we did this, it completely changed the way we ship things. Right? Because instead of being a manual process, now you have those big the trucks come on the port, and you have the cranes that take the things from the truck and put on the ship, take out of the ship, put for customers, you know, it's approved from customers, put in the truck again, take out of the truck, put on the train, right? It's a whole process. It's an invisible revolution, right? Today we have only about 6% of the world's ships are container ships, but they carry 90% of everything that we use, right? You know, the microphone that's in your hand, the shirt that you're using, this chair that you have, that you're sitting on, all of those things have been transported using containers. Containers have been so efficient in doing all these that it's cheaper for you to fish salmon in Norway, send it to China to be chopped into pieces, and ship it back to Norway to be sold in restaurants than it is to pay someone in Norway to chop the salmon, right? Because containers adds only cents to the final price of the product. And you know, it's completely changed everything, and we don't even see them, right? Well, we do see. There's even people living on containers those days, right? You know, there's so many of them, right? We pass it by on the roads here from Huntsville to Atlanta, and you know, we pass it by this house, it's like a big container, right? Cut in the front. Actually, we had dinner in a restaurant in Dallas where, you know, we were having dinner inside this big container because it was like a truck manufacturing place. So, you know, containers are everywhere, but we don't actually see those things, right? So what does have to do with software? How do we ship software today, right? It's pretty much the same thing. You know, you get to this, you know, you were doing some software development like, oh, you know, this Java thing is pretty cool, right? So you say, you know, you get your production guy, hey, we want to run Java now. And they say, you know, how do you run Java? Well, you know, you have to start Java like this. It's a JVM. You start like this. You stop like this. You do backups of the JVM like this. Okay, so I got it. That's fine. And then, you know, comes Tommy Tribe along in the lane. Said, you know, oh, you know, I saw Otavio talking about this Java EE server, right? So we should use Java EE here. Well, Java is different than Java, right? Yeah, it's different, but it's pretty similar. It's a Java VM also, but it's an application server. You run pretty much the same thing. It's a little bit different. Okay, so we can handle that. And you know what? And then you have this open source guy here to say, you know, you should be using PHP. Well, PHP is Apache, isn't it? You can just run PHP inside Apache. That's easy. We know how to handle Apache. We can then do this. And then, you know, comes along this Bruno guy saying, you know, you have to use this issue tracker here. That's very cool. You know, Redmine is written in Ruby. No Ruby here. You know, we had to learn Java. We had to learn Java EE. We had to learn PHP. We're not going to do Ruby, right? We're not going to do any more of this thing here, right? We're going to do, you know, it's too complicated for us in production to manage all of these, to guarantee everything's running. So we're going to stop this nonsense. Now, everything here is going to run on Tommy EE version, which version it is? Version 7, right? And it's going to be on Java 7. And that's it. We're not changing this anymore for the next 10 years. Right? That's how things goes. Because there is a tension between developers and operations. Right? There's this big tension between those guys because developers, what do we do as developers? We do innovate. Right? We create new things. We do things differently. We innovate. And what operations does? Who knows what operations does? What do they want more? Keep things going. Thank you very much, sir. They want stability, right? And so every time, what is the biggest problem against stability? Change, right? So every time you change something stop working. So what happens? Production says no change. And then you get some guys like him, oh, I'm still using Java 6, right? You know, because someone decided no change, right? It's not because you have to run it. It's because someone does not want to change things. And that's why this whole concept of DevOps, right? Who has here heard of DevOps? Yeah, you know, developers plus operations working together, right? And everyone, we talk about DevOps, we think about, oh yeah, now we're going to have this cool thing, right? We're going to have this one single team that's going to do everything. That's DevOps team, right? The truth is, most companies have like a dev team, an operations team, and now we're going to have, you know, we're going to merge together in one team. So they create a third team, like the DevOps teams, right? So now, before you have the dev fighting with the ops, now you have the devs and the ops fighting with the DevOps guys, right? The problem with that is that for us to actually have that, we need to have a common way to talk between those guys. So what is the common way? Containers. The same way the containers made it easy for us to do shipping. Containers are going to completely change the way we do shipping of software. Because now, you as a developer, do you want to change? So you get a Java application, you put inside a container, right? You get a Java 9 application, you put inside the container. You get a Java EE application, you put inside the container. You get your PHP application, you put inside a container. You get your Ruby application, you put inside a container. And you give to the production guy, here's my container. Production knows how to start a container, stop a container, back up a container, do load balance of a container, get the container from your on-premise, from your application, your laptop, and move into a test environment. Get from the test environment, put in your Jenkins for whatever you want to do. Get out of Jenkins, put on your production server. Take from on-premise and put on the cloud. Move into multiple cloud providers. You can do all of these with the containers. Because production, they have the tools to do this, right? They have the cranes and all the process to do all of these. Well, the same way that you'd run, let's say if you have this big box, like this big metal box, and you get into a port that does not have cranes, what do you do with it? Right? You get like 20 guys to carry it like crazy and push into this little boat that doesn't fit, right? You need the tools to do this. The same way with containers, right? It's very good containers, great. We can use for lots of things, but if you don't have the tools, you can't do anything with that, right? So that's where we are right now. We are in a very, very important moment of software development because the shipping, the ships, right? When the real containers were introduced, there was very little, when the shipping containers were introduced, in a ship, you carry a few hundreds containers. Today, the largest container ship, they carry 15,000 containers, right? They are huge ships, right? So it's the same thing. The Amazon Container Service is about a year old. Google released the container service less than a year ago. Microsoft released their container service a few months ago, right? We're all, Oracle acquired a container company at the end of last year, right? They just announced their container solution right now. So, everyone is announcing their first ships of container coming on. Now, if you guys are ready for packing your application inside a container, you are ahead of the pack, right? You're using, you're going to have some problems right now. Yes, nothing's perfect. A lot of things are still having to be adjusted, but you're going to be way ahead of the pack. So that's a very, very good moment for you to be experimenting and testing out of containers, right? So let me just quickly go through here. So I'm just going to go very quick here. But if you go to this URL here, jav.mn, javaman./dockerjee, you're going to get to our article. There's a series of 3 articles that go step by step, and we'll show you all of these. You can actually go do this on your time, on your machine, and you can run all of those containers for you, right? So let me quickly do this here. So everyone got it? Okay, I know some people are taking notes, but got it? Okay. javaman./dockerjavae. Okay, so I don't know why the key's not working. Nothing's working here. Oh. Yolanda, you have a window in front of everything, so it doesn't work. That's good. That's great. All right. Okay. Does it work now? All right. Okay. So you all been used it about containers here, right? Because you all, a lot of you raised their hand that you use Java EE at some point. So there's a lot of containers in Java EE, right? So you know how I was looking for that time right there. Which time is works? There's 2 different times. You say 3 minutes, that one says 5 minutes. I'm going to use the one that's longer. Sorry about that, right? So, you're using with the Java EE containers thing, right? So why we have Java EE containers? Because now you can have your Java EE application, and you can move your application from one container, from one vendor, to another container from another vendor without changing the application, right? One cool thing here. Let me. A lot of people ask us, has been Java good for Oracle? Has been Oracle good for Java? Let me just have parentheses here. A lot of people ask if Oracle has been doing good things for Java or not. And yes, Oracle has been doing great things for Java. You know, OpenJDK is way better now than it was in Sun's time. The JCP is way more active than it was in Sun time. So there's a lot of good things that Oracle has been doing, right? But as you see here, you see the Java 2 EE server. That's old. You know why? Because Oracle changed the thing. It was like this. It's not like this. Pretty boring, isn't it? I kind of prefer the colorful ones, right? So okay, so that you know, let's keep the fun in Java, Oracle, please. All right? Okay. So you know, you have all these containers for Java EE, but what about the application server itself, right? You know, you have to configure application server, install the application server, configure the operation system underneath it. If you want to move your application server from one vendor to the next, what do you do? Right? You reinstall everything again, right? You go there, you install your application server, you reconfigure everything. So that's why, just kind of skip here. That's why if you want to do in a higher level, right, we can actually have what we call the Docker containers. We can pack the whole application server inside a container and ship that thing, the whole thing, instead of having a lot of configuration, right? So let's see how that works. You know, you got Docker. You saw Otavio typing here, and you have, you know, let's say you have your Java EE application, your war file here, right? So I'm just passing as an argument here, and then you can build your container, right? So with that command docker build, right? And you know, I'm gonna give a name to it, right? So I'm giving a name to this image, Tommy war, right? And so I'm gonna pack it, right? How do I actually do this? There's one more thing. Did you notice what just happened? Did something change it here? From here? From here? Oh, there's a little dot there. Yes. So this dot here, it means that we have a file called the Docker file in this directory that defines what we want to do, right? What we want to build. So Docker allows you to script what you want to construct, right? So here I'm saying, you know, I'm starting from an existing image, that's Tommy EE image. I'm adding some configuration for my high availability settings. I'm adding some users, right? You know, I'm just kind of doing some basic configurations here just so we can do the demo, right? And then I'm adding the JDBC jar for Postgre. And look here. Here I add my war file. Remember that I passed as a parameter my application? I'm adding my war file. Once I finish this process here, what happens is that I created what we call an appliance. I create an image that contains the application server with all the configuration and my application all pre-configured, ready to run. Right? So now I have this thing ready to run, and what do? I can just run it, right? I can create a, you know, object-oriented, right? So you know there's classes and objects. Classes is the definition. The object is the thing running, right? So the same thing. The image is the definition, but when I run create, I create an instance of it, and it starts running. So I create 1, I create 2, 3, right? So I have 3 application servers running inside containers. And then I can create another one. This one I'm using a pre-made image that I'm just going to download from the internet. I don't need to do anything, just do this. It automatically downloads the image from the internet. And it has some special configuration, like there's a little file here with some special configuration. And that creates my load balancer. So I have 4 containers running my application, right? They're not running yet. You know, I have to start them, right? So I do Docker start, all those 4 guys, or I could even do, just instead of create and start, I could just run this Docker run, that creates and start at the same time, right? So with this, I just created a fully, a complex system, right? With 3 high availability containers running Tommy EE, plus a load balancer that will distribute the load to those guys, right? So you can hit the browser here and access any of the guys. I just did this with 4 commands, right? So I don't need to go and kind of install things, configure things, blah, blah, blah. Everything can be run inside Docker. And the good thing now is that I can get that stuff and do even more than that, right? I can, the cool thing about Docker is that it has a registry, it has a repository where I have a lot of pre-made containers in the internet, right? So I can actually just go on the internet, all of my Docker containers, and I can just say, well, I need a Tommy E application server from right there. I need a Postgre database from right here. I need a ActiveMQ messaging system from right there. I need a Cassandra NoSQL database from somewhere else. I'm going to just tie all of those guys. Oops, what did I do? Sorry about that. It's a sign, right? Because time is up, right? So, I can just get all those containers from all kinds of places and just connect all of them with each other, right? And once I do this, what do I get? I get my full system configured, ready to run, easy to do. Now, the cool thing is I'm doing this in my laptop. I can just run the same 4 commands and run it on my test server. I can run the same 4 commands and run my production server. I can run the same 4 commands and run an Oracle container service. I can run the same 4 containers and run any other provider with their container service. And then I can really have this thing running anywhere that I want, right? So, just the last thing I'm gonna tell you then is that if you guys, I'm just gonna close. Okay, where is? Oh, you close all the windows? No, right? Where's my windows? Okay, let me just kind of come here, right? What we're doing here during the tour, let me just kind of quickly give you then a gift for everyone. During the tour, we got one of our sponsors to give you a very, very good container platform that you can test out with. And you can test it very easy to use. So you can just come here to this QR code or this URL right there. And you're going to get a special trial out, right, for this container platform from the guys from Gelastic, right? And on that container platform, I'm just telling you guys that it's so important for the container. You're going to get to this page right here. And once you get to this page, you can see our pictures. Yeah, that's all of us right there. Okay, right? You can come here on this part of the page, and you see you have all the application server that you have, that you can test with. So you can just here click any of these application servers, right? Just let's say Glassfish, for example, right? So the Oracle application server. You click on this thing, it's going to open up, name, email, say install. It's going to send you an email just to confirm your email, and you're going to get this application server running inside a container. So you can start playing around with containers, completely free, right? It's a special account that gives you way more benefits. So go through here to this URL I sent you instead of going directly on their trial, because through here you get way more resources that you can play with, right? So, the whole idea of containers will give you the means for you to get your development, innovate as a developer, but give to your production guys exactly what they need to experiment, to run the things, right? So they can have the tools to do that, right? I see some people taking pictures yet, so I'm just gonna get out of the way here. Yeah, I'll talk from here. So I talk from the guys on the camera. You guys can take a picture of the screen. All right. So, that will give you the idea. So the whole discussion around DevOps, it's very good. You're going to see a lot of discussion around DevOps. But in the end, DevOps is this integration between developers and operations, right? Developers and operation not as the same team, but developers and operation working together to do what? To deliver software to the end users, right? So with that, what we can do is, instead, for you to have this good integration, what you do is you use containers as the interface for all that. Okay? So thank you very much, guys. Thanks. I'm not sure you have time for questions, but Yolanda's like, no.
Too late.
Too late. All right.
You have 10 minutes before the building.
Okay, right. So you prepare right there. All right. So last things, Yolanda Poirier, I told her, she works for Oracle. Until now, she's managed the Java Champions program. I'm not going to spoil anything right now. right? But until now, she's managing the Java Champions program. She manages a lot of things inside Oracle, a lot of the social networking, and in particular, she is responsible for the @Java Twitter account. As I said before, she has more than 300,000 followers. So put your hands together to Yolande Poirier.
Thank you. So I wanted to know again, like how many people are on Twitter? Raise your hand. Okay. Any other network, social media network? Facebook? Do you do any professional things on Facebook? Not really. Okay, so I hope I will be able to help then. So this is, right now I have 321,000 followers. So I grow out about, 4,000 a month. So I learn along the way like a couple of tricks. Like for example, what I see working really well is if your description is very clear and targeted. So for example, make sure that you're going to talk. I mean, you mentioned like the technologies that you want to concentrate on, because basically people want to know like what are you going to share and why they should follow you. So it's really important that you understand that you help people actually follow you. In the Java community, here are the top, the people with the most followers actually in the Java community. So if you, and you probably know a lot of them already, but Josh Block is very well known, Marcus as well. Arun Gupta has been a Java EE evangelist for many years at Oracle. Adam Bien has his own business, does also a lot of content online. Charles Nutter is a JRuby guy, and Antonio has a bunch of also conferences that he runs. So this is the second slide with a lot of people also who are really well known on Twitter, but those actually are doing like a very interesting type of content. So just to give you like ideas of what those people are doing on Twitter and why you could get like some inspiration also from what they are doing. Here are some examples of what they do. So Peter Lorre, for example, has been doing like very successful like quizzes, and he will be online like answering questions. So in a sense, all of those examples like don't really require you to like write articles or even blogs. How many of you are writing blogs on a regular basis? Like once a month? Yeah, one person is. So nobody really has time, right, to do a lot. So I mean, it's always interesting to see like what else could you do on Twitter. I mean, of course you share content, you can comment on things, but you know sometimes it's good also to have a little bit more interaction. So Heinz Kabutz has been also doing the same, and he also has like a newsletter that he writes every month. Sebastian, this is actually a retweet from Sebastian Daschner. He's been doing like a series of videos about, the CQRS, whatever it is. And so he's done like a series of videos, and at first so he was like sharing one video at a time. We did actually a post with all his videos, and that really also was very powerful. And the last example was like if you do like any type of presentations, of course you should mention them, and mention them not just one time but more than once, or tweet and retweet. That also is possible and works well. More examples. So Trisha Gee that I mentioned, she is actually part of the IntelliJ team, and she's also doing like a lot of tips and tricks about how to run. I mean, how to do better or be better productive with Java and IntelliJ. So Adam Bien, I mentioned. I like Mario Fusco as interesting sense of humor, and he gets actually a lot of traction as well. So it's also interesting to see like how can you be personal and find like some example out there that can inspire you. And then the virtual jug has also a lot of content. So again, online content. So when you share content on Twitter, whatever it is, I mean, that can be your content, but for example, on the Java handle, I share a lot of community content. I mean, I would say 90% of the content is content that I find online from Java champions, for example, and or people that I know who are producing good content, publications. And I do a tweet, so either a retweet with comments, an original tweet, and often I follow those guidelines because this slide is powerful, but I mean, I tested it and it also works. So when I add, for example, pictures, and I don't mean like landscapes because that's not what I share, but I will share, for example, like a screenshot of something in an article. And all those tweets work way better. I mean, first of all, they're more visible, and then people, if you do a good job of picking also the picture or the screenshot, then people are really grateful because they get it immediately. And the faster people understand what your tweet or what your content is about, the easier it will be for them to retweet. So doing controversial topics is sometimes good if you want to drive traffic or if you have like funny videos, but often straightforward content is much better. One thing about hashtag is I don't recommend that you use many hashtags. People tend to just click on hashtags and then move away from whatever content that you're presenting to them. Also, if you build your profile, make sure that you don't have like hashtags in there, like for example, I see, for example, people will have like hashtag entrepreneur, right? General topic. So a lot of people will just like click on that and then move away from whatever, from your profile. So those are like important little tips. There are plenty of tools out there also to help you like schedule content, because you should be aware of timing. Like people will be, are more likely to be on Twitter during commute hours, so early in the morning and later in the day. They are really, the timing is very, very, very important. I mean, I tweaked my timing and I increased the number of followers by 1,000. Just like that, just because I worked on like the timing and I really tested when people were online and when they were not. So you have a bunch of tools like Buffer, Hootsuite, TweetDeck as well. So those are all like tools that can help you like schedule tweets to be at the right time. One tool that I use a lot is TweetDeck. So because you can create lists and follow. So you can create lists by topics, but you also can create a list and add like whoever you want on. I mean, like a list of experts. For example, I will have like a list of Java champion that I'm following. So very powerful. Also, if you go to any Twitter handle, you can actually subscribe to a list. And so, and those lists will, so you don't have to recreate a list of people who are expert in a topic. I just want to show you one tool, which is the Tweetonomy, because this is always fun. Let's see. So you just go to the website and you sign with your own Twitter handle. It's a free tool, by the way. And then the little experiment. Oops. That'd be no, that's fine. Oops. Okay. So you can search, for example, a profile, and then in this case, this is no, this is not working. Sorry. So and in this case, this is actually Bruno's profile, and so it gives me like a suggestion of people who could be potential match. And here I have from Bruno's account everything, right? So the tweets that he has done, like tweets analytics, how many tweets a day mentions. You can also see his history, like per day, when is he really online tweeting.
Don't stop stalking me.
So users, it's unbelievable. This is more information that you would get on your own Twitter account with the Twitter platform. So yeah, it's just like day of the week when you tweet. You're kind of lazy on Wednesdays.
There's no time of day that you're not tweeting.
Well, that's because he's traveling.
Yeah, okay.
Rig the system. That's how you do it. So, okay, so that was it. Any questions? Do we have time for questions? Two questions? 2 minutes? 2 minutes. Okay. Questions? No questions. So you're all doing so let's see, how many followers do you guys have? Like, who has more than 10,000? Nobody? Okay, 5,000. Okay, we know that's good. Okay, more than 1,000. Good. Yeah, Facebook doesn't count. Okay, 1 person, that's good. Okay, so more than 500? Okay. Okay, well, I give up then. So I hope at least that it gives you like some ideas on how to be really, not spend a lot of time, but just be effective and do more and share more information and find the content. So no questions. Okay, cool. We're done.
Okay, guys, we're not gonna have the time to do the discussion about careers, so that's don't get out. So let me just kind of open up. Yes, what do you wanna do? Go ahead.
No, it's your window that.
Oh yeah, right. Open my window right there. Okay.
Where is it? No, you have to enter that.
You close out the window. Okay.
Enter.
Yeah. Talk something in there. No, talk something there. I'll say hello.
Okay.
I'll do this.
I'm supposed to be talking.
Yeah. Just so we can give one last.
So
thing.
we just want to show you a last resource that you can use, and that's actually something that Bruno has prepared
Just gonna get this thing here.
about career, because he was also part of my slides of people I actually follow, and also the type of content, because he does a lot about career building. So
Yeah, I just wanted to say really quick. My name is Bruno Souza. I help developers, Java developers like professional Java developers like you, to learn how to share what you know, so you can get work in great projects with great teams. And I really think you should follow all those guys here on Twitter. They're all doing very, very cool stuff on Twitter. Of course, @Java is the main Twitter account for Java, and if you're not following @Java right now, I suggest you do. But we do have on this URL here, java.mn/secrets, we have a very cool initiative called the Career Secrets, where we've been interviewing Java developers all over the world. There's lots of Java champs that were interviewed there, and they've been sharing their best career secrets to improve their careers, right? So since we did not have time to do career discussions, if you come to this URL here and you register on the list over there, I'm going to invite you guys to come to a career conversation, like a webinar, that you can come and we can discuss about your career. But more than that, right after when you finish here this tour, what I'm going to do is that I do this from time to time. I'm going to open up my agenda, and I'm going to do career discussion, like one-on-one career discussion. So if you want to improve your project that you're working on right now, if you want to go open other opportunities for your career, I'm going to do a one-on-one discussion with you, right? So watch out on the mailing list, because I'm going to announce when that's going to happen. In the beginning of the year, I did 120 hours of one-on-one conversations, no strings attached. You know, just want to help you out, improve your career. So, you know, if you want to do this, come here with us. Take a look at the Career Seeker. There's a very cool career checklist there that you can, with step-by-step things that you can do for your career. So, although we didn't have time to go over this, you can come online and take a look. And if you come here and you register there, you immediately get an email from me, and then you have my contacts, and you know, you can send me your questions, and I'm going to help you out on your career. Okay, that's it. All right. So thanks very much, guys. Thanks a lot.